Now we shall discuss the last case when the complex number lies in the fourth quadrant. So, let us name this. This is the real axis, imaginary axis, and this is O, and we have Z equal to, now it lies in the fourth quadrant, therefore Z will, how does it look like? The real part is positive and the imaginary part is negative. So, it is A minus IB. Therefore, let us draw the radius vector OP, and from P draw a perpendicular to the real axis. Now, let us name this as A, then this is OA is A and AP is B and OP is of course the radius vector R. Therefore, what is the acute angle here? This is the acute angle, we call it as alpha, and we know that alpha is given by tan inverse B by A. Therefore, what is the argument here? The argument is the angle made by the radius vector with the real axis. Therefore, this is the, but the direction you note, it is, we are measuring downwards, so it will be in this direction, theta. But however, theta and alpha, they measure the same. But can we say theta equal to alpha? No, because we want in the positive direction of real axis. Therefore, we say here theta is equal to negative alpha. Therefore, the argument of Z is theta equal to negative alpha. Let us summarize these results. And this is O. If Z lies in the first quadrant, then we said this is angle theta and theta is equal to alpha, where alpha is equal to tan inverse B by A. Okay. In the first quadrant, it hardly matters whether you call it alpha or not. Theta, whatever it is, the acute angle is same as theta. And in the, this is the first quadrant, this is the second quadrant, third quadrant and the fourth quadrant. So, if it lies in the second quadrant, then this is the angle theta and this angle is alpha. Therefore, in the second quadrant, theta is equal to pi minus alpha. And if it lies in the third quadrant, the angle is alpha and this angle is theta, right? Therefore, theta is in the third quadrant is equal to negative pi minus alpha, because it is measured in the opposite sense. And finally, if it lies in the fourth quadrant, then this angle is alpha and this angle is theta, but theta is measured in the opposite sense. Therefore, we have theta equal to negative alpha. So, this is how we find the argument of any complex number. Now, we shall do a problem. Find the argument of the complex number negative 1 minus I root 3. So, let us call Z equal to negative 1 minus I root 3. Observe that if you compare with the standard complex number A plus IB, then A, the real part, this is equal to negative 1 and B equal to negative root 3. Therefore, both of them are less than 0. Now that we have found the signs of A and B, we can clearly say that this complex number lies in the third quadrant. So, let us plot this complex number in the Argand plane. So, we shall call this the real axis, this is the imaginary axis and this is the, this point is the origin O. Now, we have decided that this lies in the third quadrant. So, this is the third quadrant. Therefore, let this be the point P. Now, we shall join OP, that is, we shall draw the radius vector OP So this is the radius vector OP we have. And then what we are supposed to do next? Drop a perpendicular to the real axis. So therefore, this is called this as A, and this is of course perpendicular. And then locate the acute angle. So this is the acute angle alpha, and of course OA is A units and AP is B units. From this we can find alpha. So alpha is equal to, in fact, tan alpha is equal to B by A. So therefore we have tan alpha is equal to B by A, and note that use the absolute sign, or we have alpha equal to tan inverse or arctan B upon A. Now we are ready to find the amplitude or the argument of this complex number. Therefore the argument is this angle theta, right? So this is the angle theta, which this R, this is the radius vector, makes with the real axis. But one thing to note, this is measured in the opposite sense. Therefore what we need to do is, after finding theta, so in terms of alpha, so theta will be here pi minus alpha, clearly pi minus alpha. Since we are measuring in the opposite sense or in the negative direction of real axis, so I have to attach a negative sign to this. So this is the argument of this complex number. So we can say theta is equal to negative pi minus alpha. Now first let us find what is alpha. Alpha is equal to here tan inverse B upon A, that is negative root 3 upon negative 1, and with the modulus sign. From this we get tan inverse root 3. So this is what is alpha. From trigonometric tables we can say that alpha is therefore pi by 3. So from this we get alpha as pi by 3. Now we have alpha, we can put the value of alpha in this to get theta. Theta is equal to negative pi minus pi by 3, or simplifying we get 3 pi minus pi, that is 2 pi upon 3. So theta is equal to negative 2 pi upon 3. So clearly what was the condition? Do you remember the condition for the argument? Theta must satisfy the inequality negative pi less than theta less than or equal to pi, and this clearly satisfies this inequality. Therefore our argument, we shall write arg of z is equal to negative 2 pi upon 3. So this is our solution.